Okay, so this is the graph that I made, and I have N2 and F2. I don't really know how they want us to write it. It just sort of said F2, so I kind of had to just assume that this is going to be an N2. And then I put the N2 curve, and this point right here is going to represent the internuclear distance because it's on the lowest point of the x-axis. Well, so it's the lowest point of the y-axis, but it's this x-axis mark right here is going to be the internuclear distance, but that's also the bond length. So that's going to be the bond length. And then potential energy increases on this side of the graph because it's a repulsion, because the two nucleuses get too close and they start repelling each other. And then here they are at the lowest point because this is the perfect distance. It's the bond length. It's where they're stable. And then you go up and they're further and further apart. So then as you come down, they're closer and closer, and the attraction is growing. And then it plateaus because they're so far that there's no attraction. Sort of shows the attraction because the attraction is increasing, and then it's decreasing because they're so close that now they want to repel. And then the potential energy of nitrogen atoms, you're gonna basically, fluorine atoms, you're just gonna take it and shift it to the left because this atom is going to be smaller than nitrogen. They're in the same period, but this one is in a higher group than this one, which means that it's going to have a smaller radius because of the nuclear attraction, which means the internuclear distance is going to be shorter because a shorter radius is going to result in a shorter bond length. And we've established that where this point is the bond length, so you're going to move it to the left.